I'm Anil Kumar, and in this video, we'll understand a very amazing strategy to factor something which we thought is not factorable. That is, sum of squares. Well, some of you will say you can factor sum of squares in complex numbers, but no, we are working for sum of squares in real numbers. So the question here is, factor x to the power of 4 plus 9, where x belongs to real numbers. So that's the question for you. You can pause the video, answer the question, and then look into my suggestions. Now let me first discuss why we cannot factor it, right? So it is unfactorable. So if I have to plot this graph, it will look something like a parabola, of course, with the wider turning point, something like this, where if I substitute 0 for x, I get 9. So this point is 9 for us, and that is x-axis, and this is the y-axis. So as you can see, it is not crossing the x-axis. It has no x-intercepts, right? So it has no real roots, right? Since it does not have any real root, what do we conclude? That it cannot be factored. Right, so this is what we have learned so far. Now, here's the strategy. So I will not call this as a trick. We are now looking into a strategy, right? It's a very, very important strategy to understand. Let us see how to factor it. Okay, so to begin with, I will take a binomial x squared plus 3, which is very close to this, right? And I'll square this. So if I square this, what do I get? I get square of x squared, which is x to the power of 4, plus 2 times these terms. So that is 6x squared, and then 3 squared. We get plus 3 squared is 9. This is what I get. Now if you compare, I have these two numbers, that is, I have x to the power of 4 and 9, but I do not have 6x squared, and therefore I've come up with this strategy. What we can do is we can write x to the power of 4 plus 9, that is given to us, right? We can add 6x squared to this and also subtract 6x squared. So basically we have the same thing as x to the power of 4 plus 9. Do you agree? So I'm writing that the given question now can be written as x to the power of 4 plus 9 plus 6x squared minus 6x squared. Now see what I do. I'll just rearrange, so I'll get x to the power of 4 plus 6x squared plus 9 minus 6x squared, right? Now if I do that, in that case, these three terms form a perfect square, which is x squared plus 3, right? So which is x squared plus 3 whole square, right? And I have 6x squared. Now, 6x squared could be written as square root of 6x and then whole square, right? Kind of. Okay, so I could write this as x squared plus 3 whole square minus square root of 6 x whole square, right? And now I can do difference of squares, which is, we know a square minus b square could be written as a plus b times a minus b, right? So I could write this as x squared plus 3 plus square root of 6x times x squared plus 3 minus square root of 6x, right? So that is how I can factor. Now we are multiplying two factors. Therefore, x to the power of 4 plus 9 could be written as, in factored form, x squared plus 3, or you can rearrange it, right? Write square root of 6x first. You could do that. And x squared plus 3 minus square root of 6x. Well, some of you will say, we got square root of 6, right? So that is not cool, right? So what you can do is, you can apply the same strategy to a different number. I mean, you could factor, so try this out. So this is practice for you. Try this out. We are saying x to the power of 4. I took 9 and therefore I got some number which was not really a perfect square, right? So we could take x squared, x to the power of 4 plus 1 and figure it out. Or you could take x to the power of 4 plus 4, or you could take x to the power of 4 plus 16 if you don't want to see square root, correct? Try with these. Same strategy. It will work. You'll be in a position to factor them, and that is what we have learned in this video. It is very important. I'll give you a link for my solution to x to the power of 4 plus 4. I hope that helps. Thank you and all the best.